Hello, I'm Bill Inmon, and it's a real pleasure to be speaking with you today. I want to talk with you today about my favorite topic, data architecture. In particular, I want to talk about data lakes and the architectural implications of data lakes. You see, a lot of people have built data lakes, and they're waking up to find out that the thing that they built is not very useful. So I want to talk with you today about taking a data lake and turning a data lake into an asset. So how did all of this come about? Well, one day the corporation found that it was deluged with data. It had data coming from all over the countryside. It had data coming from customers, from competitors, from the government, you name it, from the internet. And this is where corporations find themselves, that there's so much data that they need a rational way to handle all of that data. So a vendor came along, I'm not sure who it was, and said, "Oh, what we need is a data lake." And so what the vendor said was, just take all this data, put it into a data lake, and then at a later point in time, you can come and analyze your data. And this sounded like a good idea. It was easy to do, didn't require much planning, much forethought. You just took your data and threw it into a data lake. And this is what a lot of corporations have done. And what happens when you wake up and find out what happened to your data lake? You find out that your data lake has turned into a data swamp. And what I mean by that is that no one can find anything. No one can relate data to any other pieces of data. No one knew what any unit of data meant. And so what happened was people put all this data in their data lake, and nobody ever came and did anything with it. Instead of being a corporate asset, it was definitely a corporate liability. Now, who was impacted by this swamp, this data swamp that was being built? A lot of people were being impacted by it, but perhaps the biggest impact is on someone we call the data scientist. Because what happens is the data scientist spends 95% of his or her time struggling with the data and 5% of his or her time being a data scientist. Now, the data scientist has gone to school and learned all of these interesting, fascinating things about statistics and correlation and all kinds of different charts. But when they get out to the real world, they find they don't get to use those skills. What they find is that they end up struggling with the data. And when your data is wrapped up in one of these swamps in your data lake, you find out that your data scientist is the person that suffers the most. Now, this is a terrible waste. Why? Because the data scientist is turned into a data garbage man. And this is a waste of talent. This is a waste of time. This is a waste of money. And this is a waste of opportunity. In short, this just isn't a very good thing to do. You don't want your data scientist turning into data garbage men. Can't we do better than this? And the answer is yes, we can do better. We need to take our data lake and convert that data lake into something that's called a data lakehouse. And a data lakehouse then is a useful structure where people can do things that they need to do, can find data that they need to find in their data lake. So we find then that yes, these data lakes that we've created can be saved, but it's going to take some old-fashioned work and innovation in order to do that. Now, I'd like to make a point here before we go any further. Sometimes people confuse a data lake with a data lakehouse, and they are not the same thing at all. A data lake is a collection of garbage data, and a data lakehouse, as we're going to be seeing in a few minutes, is a very organized, very prolific, very well put together a collection of data that lends itself to doing analytical processing. So, what do we have to do to turn our data lake into something useful? What do we have to do to turn our data lake into one of these data lake houses? Well, the first thing that we have to do is to create something called an analytical infrastructure. And the analytical infrastructure is what allows us to find data. Then the second thing we have to do is make sure that the data that we put into the data lake is integrated data. Now, we're going to talk about what we mean by integration, but we don't just take data and throw it into the data lake. We integrate it before we put it in there. And when we put the analytical infrastructure on, and when we integrate our data, we turn our data into a data lakehouse. So this is the high-level view of what's needed to turn your data lake into an asset. Now, in order to understand this, we need to talk very briefly about another subject. We need to talk about the different kinds of data that you have in your corporation. And typically, the different kind of data that you have in your corporation is structured data, text, and analog IoT data. Now, there are probably other kinds of data in your corporation, but from a decision-making standpoint, these are the three kinds of data that you find in your corporation. And it's kind of interesting. Each of these different kinds of data have their own characteristics and properties. Anybody thinking it's all the same hasn't worked with this data before, because these different types of data are definitely not all the same. So let's talk first about structured data. And what do we need from, where does structured data come from? Structured data typically comes from transactions. When I think of transactions, I think of bank tellers, I think of airline reservation systems, I think of telephone companies with huge amounts of information about phone calls and so forth. And so so that's what we mean by structured data, where each of the units of data found are the same. The contents of structured data are certainly different, but the structure of the structured data, in fact, is the same. So when I look at my structured environment and I look at the need for an analytical interface, what do I find? I find that I need such things as metadata, a data model, transformation algorithms, summarizations, records, keys, attributes, indexes, and so forth. This is the kind of information that I need when I'm dealing with classical structured data. And this is what's going to be going into the analytical infrastructure. Now let's talk about text. It turns out that there's a lot of text in your organization, and the text in your organization is something that contains a great deal of business value. And I find it to be amazing that corporations around the world don't do much with text, but such things as you can find in text are the medical records. Medical records are wrapped up in text, but if you want to do medical research and look at 100,000 patients at a time, you need to convert those medical record text into a database. Something called the voice of the customer. The voice of the customer is what people, pardon me, what people are saying about your company, its services, and its products on the internet. What do people think of what you are producing? And that's just the tip of the iceberg when it comes to text in the corporation. There's a tremendous amount of text in the corporation, and it typically does not get used in the decision-making process. And that's a real shame. So when we look at textual information, what kind of information do we find in the analytical infrastructure? We find that when it comes to text, we need to deal with things called ontologies, taxonomies, something called inline contextualization, something called annexes, and transformations. These are all of the kinds of things that we need to use to look at and make sense of text. Now let's take a look at the analog IoT analytical environment. In the analog IoT environment, we need to look at such things as the distillation algorithm, thresholds, and time boxes. And there's a whole wide variety of other things that we need to look at when we look at the analog IoT environment. Throughout all of this, there's another component that needs to be looked at, and that is the component of data lineage, that we need to know where data came from, where it goes, how it traverses through the organization. So these are the kinds of things that we need in for our data lake to turn it into a data lakehouse. The elements of data lineage. What do we look for when it comes to data lineage? We look for such things as the algorithm of summarization, derivation, and transformation. Because you see, as data traverses throughout the organization, it's constantly being transformed, derived, summarized, etc., and so forth. Second thing we need to look for is the algorithm of selection, that when we move data from point A to point B, in some cases, we don't move all of the data, just some of the data. So we need to know what those algorithms are for selecting what data gets to be moved in terms of lineage. Another thing we need to look at is the timing of execution, that when we are looking at the movement of data, the actual timing of the movement is something that's important as well. And all of these elements belong in the lineage of data, as well as other elements. Now, another thing that we need to do when we move our data into our data lake, in addition to building the analytical infrastructure, we've also got to integrate our data. And integration is typically done through something called ETL from the structured data, textual ETL from the text environment, and distillation algorithms coming from the analog environment. So let's discuss each one of these. Let's start with the structured environment in ETL. What do we mean by integrating data from the structured environment? Well, typically, data from the structured environment that needs to be integrated is application data that's transformed from an application environment into an enterprise environment. And as an example of what we mean by the transformation of application data to enterprise data, here we have three structured applications. And in this application, we have gender, dollar, and measurement. And in one case, gender is M and an F. Another case, gender is male and female. Another case, gender is 1 and 0. When it comes to dollars, $1 amount is in Australia. Another dollar amount is in Canadian. Another dollar amount is in United States currency. When it comes to measurement, one application measures things in centimeters. Another application measures the same thing in inches. Another application measures the same thing in feet. And each of the applications has selected their own way of doing things. Well, when it comes to having an enterprise understanding of information, we need to have a singular way of understanding our data. For example, we can choose gender to be male and female. That's simple enough. We can choose the dollar amount to be in USA dollars. We can choose measurement to be in centimeters, so that when we go to do analytical processing on enterprise data, we understand what we're talking about. Now, this is what's meant by integrating data as we put it into the data lake. We don't want to put this application data in the data lake. We want to put integrated enterprise data in the data lake. Now let's go to textual ETL. Integrating text, it turns out, is a much more difficult thing than integrating the structured data. And so what does textual ETL do? Textual ETL reads raw text and places the relevant data into a standard database. That's what textual ETL does. So what are the issues of textual ETL? The issues of textual ETL start with, where does the text come from? Because you see, text can come from many, many places. So we can have text coming from voice, database, email, internet, print, and there are other places where text comes from. And we need to be able to handle all of these many sources of text. The second consideration is that text is complex. For one thing, text can be in English, French, Spanish, Portuguese, or German, or some other language. That's one of the challenges of text. A second challenge of text is that text can either be in a formal language, like a professional writer would write. It can be in a comment. It can be a slang. It can be a colloquialism. There's all kinds of ways that text comes to the world. And textual's got ETL has got to be able to handle all of these forms of text. But the real complexity of text is that in order to make sense of text, you've got to have context as well. And the problem with context is that context comes in an implicit form with text, as opposed to the explicit form of context that comes with structured data. So what we have is the notion that when we go to read text, we certainly need context, but determining what that context is a very difficult and complex thing to do. So that's a little bit about getting text into the data lake. We've got to put text into a form of a database with both text and context in the data lake, if our data lakes are going to make any sense at all. The third kind of processing we've got to do is processing in a data lake. And the processing in a data lake is very different from the kind of processing that we do when we are working with textual data or structured data. So let's talk about what needs to go into the data lake when it comes to our analog IoT data. Now, what is analog IoT data? Analog IoT data is data that's created by a machine, and a machine, an electric eye, a drone, a temperature gauge sits there and takes measurement after measurement after measurement, usually in a manufacturing process or some other type of process. And machines can generate a huge amount of data compared to everybody else. So what we find is that when we look at machine-generated data, analog IoT data, we find out that the vast majority of the data that we have is data that has no business value. There's a small amount that has great business value. And now, in order to understand this, consider yourself to be, just for the next few seconds, one of these cameras that they have for surveillance in a parking lot. And throughout the day, you see normal activities in the parking lot. You see people coming and going. You see the parking lot empty at nighttime, and that's what you as the camera see. However, every now and then there's either an accident or a break-in into a car. And at that point in time, the camera, the images taken by the camera become very valuable. So we see that the vast majority of the images taken by the camera are not useful at all, but some of the images are very, very useful. And that's what we expect to find when we go out to analog IoT data. Now, what we need to do is we need to distill from the data that's been collected the data that has business value, because we don't want to put all of the data coming from the analog world into our data lake. We only want to put the data that has business value. And we do that through a distillation algorithm. So this is what needs to go into the data lake. So here we have what the data lake looks like when it's been transformed into a data lake house. We see the analytical infrastructure with its different components. We see the transformation of data coming from the different places. We see the need for data lineage. And this is what it takes to convert a data lake into a data lakehouse. Now we can start to do serious analytical processing in our data lake. And once you've done that, a lot of people are happy, but the person that's the happiest is the data scientist. The data scientist is the person that is now a happy camper, because the data scientist can now be a data scientist rather than a data garbage man. And you've got other users out there that are happy as well. So this is what it takes to turn a data lake into a data lake house. This is what it takes to create business value in your data lake. Thank you for your time. I hope that you found this presentation to be interesting and useful.